Hello everyone, this is DSA Zindabad. Today we are going to solve the 12th question of our DSA sheet, and the question is container with most water. Now let's look at the problem statement. You are given an integer array, height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height of I. Find two lines that together with the x-axis form a container such that the container contains the most water, and you need to return the maximum amount of water a container can store. Notice that you may not slant the container, right? Now just look at the example. So initially we'll be given an array, right? Let's take this array, which is 186254837, right? And each of the vertical line represents the height. This is the height, right? And what we need to return? We need to return the maximum amount of water a container can store. So how can we find out the maximum amount of water a container can store? This can be find out by the area, which is length into breadth in case of rectangle, right? So let's say uh, we have this array. We are at this position, which is this is 1, this is 8, right? Now, when we consider these two lines, 1 and 8, this will be the amount of water which can be stored. And its area will be equal to length into breadth. Here length is equal to 1 and the width is also equal to 1. So ultimately its area will be equal to 1. Now, as we traverse over the array linearly, what we can find out the 8th line, which is of 8 length, and the line number 7, this is line number 7. These both can store the maximum amount of water. How it can store maximum amount of water? Because its length will be equal to 1, 2, 3, 4, 5, 6, 7, right? And its breadth will also be equal to 7. That's why length into breadth, 7, 7 is 49, right? And we need to store the amount of water such that it cannot spill over the vertical line, right? What do I mean by this? Let's say this is the height 8 and this is the height 7, right? So the height which is have less value, this can be considered as our height, right? Because as you can directly see, when we fill the water over the 8th line, the water can spill off, right? So we need to take care of this thing also. Like we cannot split the water out of the container, right? So what we need to return? We need to return the maximum amount of water a container can store. Now let's take a different example, a short example. You can say so that this problem is clear to all of you guys, like what we need to return, right? Let's say we have this line. This stores 1 and this stores 2 and this also stores 1. This stores 2, sorry, 3. And we have this line and this stores 2, right? This is our example. Let's say this is our array, right? Now let's say we try to store the water in this, so its area will be equal to 1, right? Now we move ahead, we'll try to increase the length by 1. Now it can store the area equal to 2, right? Now its area will be equal to 2. Now we'll again try to increase the length. Now it can store around 3. Now it will store 4. So initially what we are doing, we increase the width. We increase the width, right? We are not concerned about the you can say height, right? First of all, we try to increase the width to the maximum level, right? We'll try to increase the width to the maximum level. So it will be storing 4, which will be equal to 4 into 1, since height is over there 1. So it will store 4, right? This whole amount of area. right? Now, when we talk about, let's say, this can be also be our answer. This is the width to be 2 and the height to be 2. But this will ultimately store 2 into 2, which ultimately equal to 4. So as you can see, like we can just traverse over the array and find out whose area will be maximum, right? Now, there are multiple combination also, like we can store the voter in this way also. Like this length will be equal to 1, 2, 3, right? 3, and the height of this will be equal to 2. So ultimately this will store 3 into 2, 6, right? So this will be our area of the container, right? This will be the area of the container. So now let's jump into the approach, like how we are going to solve this question, right? Now let's jump into the approach. First of all, let's talk about the brute force approach. So what does the brute force approach says? Let's say we have this array, 1, for this is just some random example, 1, 8, 5, 3, 2. So what we'll be doing, we'll just traverse over the array. Like whenever we are given an array question, what we need to do, we'll just traverse over the array by following some condition. This is for the brute force approach, right? We don't care about like how many loops will require. It will just try to come up with the solution, right? Let's say we are at this element initially, right? What we'll be doing, we'll just try to get the area, try to calculate the area with all of the other elements for this element, right? We'll just traverse over the remaining array for the first element. And we'll just maintain area over there, which will be a maximum value, which will be initially 0. And we'll try to update this area with the maximum value, which will get by comparing all of those values, right? Now, we'll again move our pointer to 4. Now we'll perform the same thing for this 4 element and for rest of the other elements, right? So for this, what we are going to do, we'll require 2 nested for loops and we'll update this area, right? To be like whenever we found the maximum area, then we'll directly return this as our result. So let's talk about the time complexity for this problem. Time complexity would be big of n square, right? Since we require 2 for loops for the same, and the space complexity would be big of n. Why big of n? Because we are not using any extra space. No extra space is required for brute force approach, right? I hope this brute force is clear to all of you guys. Now let's try to reduce the time complexity of this approach. Now let's talk about the optimal solution, like optimal answer, right? Optimal solution, right? Let's take this. So this is our initial example, right? So what we'll be doing will whenever we talk about the optimal solution or the optimized approach, what comes in our mind, like we need to get the time complexity to be big of n, right? So we need to traverse the array only once, right? So how we can optimize the approach, like how we can traverse the array only once. So with the help of pointers, we can achieve this thing, right? So with the help of pointers, we can achieve this thing. So how many pointers will I require, since area is of like length into breadth? So we'll require 2 pointers because one of the pointer will be pointing to the initial start of the array and the other will be pointing to the right end of the array. Like why we are choosing this, this will be clear to all of you guys when I do the diagram, right? So initially will be required 2 pointers, right? First one is the left pointer and the another one is the right pointer. So whenever we try to calculate the area of the container, what we need to do, we need to keep one thing fixed. Either it would be width, either it would be height, right? And now again, we'll try to reduce the width of the container. What I'm Mean to say, let's say our length will be at this, the left pointer will be at the initial start of the array, and the right pointer will point to the end of the array, right? This is what I mean, like we'll just try to calculate the uh, area between these two initially, which will be equal to the like width into height, right? Which will be equal to 8 into 1. Now our area will be equal to 8 into 1, 8. Ultimately, it will be equal to 8. Now, for this, let's say we will try to increase the height, right? Because when we increase the height, we'll try to increase the area, right? Now, out of this, like out of the left pointer, the right pointer, whose length is minimum? As we can see, like length of the left pointer is less than that of the right pointer, right? So we'll increment our left pointer by 1. So now it will be pointing to this, right? Now again, we'll try to calculate the area. Now, as you can see, like this will be our area for the same, right? Now, what we'll be doing, we'll just try to calculate the area, which will be equal to 7 into the height will be 7, which will be equal to 49. Now, 49 is greater than that of the 8. So we'll update our area to be 49. Now, after this, what we'll be doing, we'll again compare the height of left pointer and the right pointer. Now we'll check whose height is less than that of the other, right? Now, as you can see, like the height of the right pointer is less than that of the left pointer. So we'll decrement our right pointer. Now, again, we'll try to calculate the area. Now, our area will be something like this. Let me just do it with some other pen. This will be our area, right? So this will be equal to 6 multiplied by 3. 6 multiplied by 3, 18. Now, since 18 is less than that of the 49, so we'll not update our area. So our area will remain as it is, which is 49, right? So out of this, what we'll try to do, we'll try to decrease the right pointer again, because the height of the right pointer is less than that of the left pointer. So we'll again try to reduce, right? So we'll came across this length. So our area will be something in between these lines, right? So this will be equal to its width will be equal to 3, 4, 5. 5 multiplied by 8. 8 5 is 40, but it's still less than that of the 49. So we'll continue until we find the maximum area, right? So at this point of time, like whenever we find the length or the height to be equal, whenever left pointer's height or the right pointer's height is equal, then we'll try to increment either the left pointer or try to decrement either the right pointer, right? Let's say we'll try to increment our left pointer. So now the area will be something in between these lines. This will be something in between these lines, right? So its area will be something equal to 4 multiplied by 6. So ultimately it will be equal to 24. So it's still less than that of the 49. So now we'll continue to iterate over the array and try to update our area as soon as we get the maximum area, and we'll update our answer. So after traversing all of the array, we find out that 49 is our answer, because 49 is the maximum value which we can get from the given array, right? So we'll return 49 as our answer. I hope like all of you guys get like what I'm trying to say, like how we iterate over the array, how we are fixing the width, how we are fixing the height, and how we iterate over the array by incrementing the left pointer when we increment left pointer and when we decrement our right pointer. I hope all of these things clear to all of you guys, right? Now let's try to code this thing up so that this will be more clear to all of you guys. Like And after this, we'll try to discuss the time and space complexity for the same, right? Now let's code this thing up. So here we are. Initially, what we'll be having, we'll have two pointers. One is left one, and the another one will be right one. And this will be pointing to the right end of the array. And we'll have maximum area as the third variable to store the maximum area, right? So we'll iterate until both of the pointer crosses each other. And in this, we'll try to calculate the area, which will be equal to minimum of height of left and the height of the right pointer, right? And this will be multiplied by the right minus left. This one is the width, right? And we'll try to update our maximum area as soon as we get the area, right? Maximum area, right? Now, if the height of left pointer is less than that of the right pointer, what we'll be doing? We'll try to increment our left pointer. Otherwise, we'll decrement our right? And at the end of this, we'll return our maximum area, right? Now let's try to submit this thing. Now submit the code. Yeah, this code runs perfectly fine. Now let's discuss the time and space complexity for the same. So here we are. Since we are just declaring three variables, so it will require big of one time, and we are just iterating over the array, so it will require big of n time, right? Now ultimately its time complexity would boil down to big of n, and space complexity will also boil down to big of 1, since we are not using any extra space. No extra space is required while solving this problem. I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.